Can we start now?
Yes, sir.
Okay. Right. Chalo, bachcho. First question is, just a minute. Okay. This is the first question. This is an integer type actually question. Reaction X and reaction Y. Two reactions are given. A number of moles of unreacted acetone left after the reaction X and reaction Y are A and B. A value of A and B you have to find. Acetone Br2 1 mole with OH negative, acetone Br2 1 mole with acetic acid, right? This is a perfect question actually for JEE advanced integer type questions. Tell me, anyone? First, you guys, please switch on your camera. Bachcho, switch on your camera, everyone.
Sir, I am not getting the value of B, but A की value 2/3 आ गई. Yes, sir. A 2/3.
Okay, should I explain this? Tell me.
Yes, sir.
Okay. Okay. Now listen. Okay, how to solve this question? Before solving this question, now first I'm telling you the concept of this halo form reaction. What is the concept exactly? See, suppose I have this acetone, CH3CO CS3, any acetone or aldehyde, anything, and we are using dilute NaOH. Okay, I think many members know this concept, but again I'm telling this. Dilute NaOH. See, any anion, they first act as a base and secondary they act as a nucleophile. First, this concept I'm telling you, right? Any anion first act as a base, then secondary act as nucleophile. But acting as a base is only fruitful if there is some acidic hydrogen we have. Carbon hydrogen is generally not acidic H. Carbon hydrogen in general is not a acidic hydrogen, right? So in that case, OH minus immediately it won't attack as a base. So they act as a nucleophile. As they attack as a nucleophile here, then pi bond will shift upward side. Now we are getting this CH3C O minus CH3 and then OH. Now this O minus driving force will release the OH minus again and reaction will go back in the reactant side. Right? Again, we are getting the acetone. So maximum. So here we can write one statement, maximum nucleophilic attack, but no result. Maximum nucleophilic attack, but no result. Now listen carefully. Maximum nucleophilic attack, but no result. Maximum they attack as a nucleophile because anion is acting as base, the first base. That is okay. But carbon hydrogen is not a proper acidic hydrogen. So initially, instead of base, they first act as nucleophile. Pi bond is shifting upward side and O minus is coming down. OH is released because we are using the dilute NaOH condition. So maximum nucleophilic attack, but we are not getting a result. Minimum they attack as a base. Now, suppose here we have this CH3, COCH3. Now, again, dilute NaOH. Maximum nucleophilic attack, no result. Minimum they attack as a base on this hydrogen, minimum, right? And as they attack as a base to this hydrogen, like this, I'll just write in a proper manner. CH2H, minimum they attack as a base, H release electron forward, we are getting CH2 minus, which is resonance stabilized, so we are getting enolate ion. Now we are getting enolate ion. So maximum nucleophilic attack, because carbon H was not proper acidic, so not acting as a base, maximum nucleophilic attack, O minus come down, again OH release. So maximum nucleophilic attack, but no result. Minimum base attack. Here I am writing minimum base attack and we get result. Minimum base attack and we get result in form of enolate ion. So what is happening? Whenever we are using dilute NaOH, so nucleophilic attack won't give result, base attack will give result because we are getting enolate ion. This O minus when coming down and pi bond is shifting here, this carbon minus and attacking on suppose Br2, we are getting this nucleophilic attack and we are getting this CH2Br. Now, again, when you use dilute NaOH, listen, so instead of fresh ketone, they try to attack on this used ketone because due to the minus I effect, this hydrogen become more acidic. So instead of attacking on the fresh ketone, they attack on the used ketone. Used ketone, if they attack, again, we are getting here, suppose here this acidic, not here, attack on this more acidic H, again enolate ion, again Br2 attack. Now we will get this CH3CO, CH2Br2. Again, if you use dilute NaOH, in every reaction, you remember, first they attack as a nucleophile, no result. Minimum attack as a base, we are getting result. And now again attack on Br2, so now 2Br. Again, maximum nucleophilic attack, no result. Minimum base attack, now again C minus, again Br2 attack, again I am getting CS3CO, CBr3. Are you getting my idea? Idea was very simple. Initially, OH minus first acting as a base, but the carbon H is not sufficiently acidic. So they first act as a nucleophile. O minus when coming down, OH again release, go back to the reactant side. So maximum nucleophilic attack, but no result. Minimum they attack as a base, but we are getting result because anion is getting resonance stabilization. When it is again coming down, C minus will hit the Br2, we are getting CH2Br. Now, if you again use NaOH, first they attack nucleophilic, won't give result. Then instead of a fresh ketone, they attack on the used ketone because this H become more acidic due to Br minus I effect. Again C minus, again Br2 hitting, now 2Br. Again nucleophilic attack, no result. Minimum base attack on the used ketone because now H become more acidic because of 2Br minus I effect. Again C minus, again Br2 hitting, CBr3. Now again nucleophile attack. And now again nucleophilic attack, again O minus. And when this O minus is coming down, so instead of OH minus, now we are having a better leaving group, CBr3. CBr3 released, we are getting CH3COOH plus CBr3 minus. That will take acidic hydrogen from acidic acid. We are getting CHBr3 like this. So if I am using suppose 100% this and Br2 3 moles, Br2 suppose, okay, 1 mole only, 1 mole Br2 and suppose 1 mole this acetone. So out of 1 mole only we have used only 1 molecule like, and all Br2 molecule we have consumed. So it means only 1/3 I have consumed, 2/3 part is left over. So write 2/3 part left over in the basic medium. Everyone got this basic idea? 2/3 part left over because every time I am using the used ketone, fresh ketone we are not touching. So all Br2, suppose Br2 I am having 100%, 100% Br2 used, but only 33% ketone we have used. So 66% जो ketone है, that is a leftover, 66%. But in case of acidic medium, Harshit, focus. But in case of acidic medium, as you are having acidic H plus condition, first this O will give backup to the acidic H because other than this you don't have any option. This OH positive, now this is the condition when it is pulling the pi bond because of the positive charge neutralization. Here we are getting cation, it withdraws the electron. Now we are getting this enol condition, neutral enol, not anionic. right? Now we have suppose Br2. When it is coming down, it is attacking on the Br2. We are getting CH3CO, CH2, Br. Now if you use again H plus, so instead of this, because of this minus I effect, pulling tendency, the donation power is reduced. So instead of this used ketone, they will use the fresh ketone. So here one acetone molecule consumed by the one Br2. So here one mole completely consumed. Then second new reaction may, in the new reaction again one mole Br2 will consume, because the next H plus won't attack the used ketone, because used ketone in minus I effect, the donation tendency got reduced. That is why in the question here one mole, this 1 mole consumed, only 1/3 consumed, so 2/3 left over. 1 mole completely consumed 1 mole, so 0 left over. So answer is 0.66. You got this question? This is perfectly fit for the JEE Advanced. Not the tougher side, but this question is because this part you may know, but this part you must know. In acidic condition, 1 Br2 mole consumed 1 mole acetone. They won't attack on the used ketone because of the minus I effect of Br. The donation tendency got reduced, so they approach the fresh ketone instead of the used ketone. You got my point?
Yes, sir.
Okay, now please go for the second question, bacho. Try this second question, bacho. Remaining student, they got the previous question, bacho. Everyone. Okay. I got your answer.
Sir, is the answer 4?
What is the answer, beta?
4.
4. Okay.
8, sir.
Answer is 8. Okay.
Optical isomerism इसमें पूछे optical activity.
आप पढ़ो क्या लिखा है?
Sir, all of them, sir.
Okay.
8.
8. Okay. Yes, everyone. Answer is 8 only. Okay. You see, all are the same compound only. Means 2, 3, 4 triol. All are the same only. It is a meso compound. This is a meso compound. This is a meso compound. This one is meso compound. These all are the meso compound. When and remaining are active, 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 and active. When any inactive compound is having active isomers, then they are called as the meso compound, right? So now, what is the definition of optical isomerism? Optical isomerism definition means the same molecular formula, different optical behavior. Listen, everyone, different optical behavior. Different optical behavior means either differ in terms of direction or they are differ in terms of magnitude. So they all are differ in terms of magnitude with the meso. Its magnitude is 0, but it is a non-zero. This magnitude is 0. This magnitude is 0. This is a non-zero. This magnitude is 0. This is a non-zero. This is again non-zero, means they all are showing different optical behavior. So means all are showing optical isomerism. So there is one definition. Any inactive compound, if having active isomers, so those inactive are called as meso. And in that case, all meso will be considered as optical isomer because they are showing different optical behavior in terms of magnitude. So they all are showing optical isomerism. If they are optical activity, then only you can say that 1, 2, 3, 4 are active only, remaining are inactive. But they are asking optical isomerism. And isomerism means different optical behave either in terms of direction or in terms of magnitude. You got my point? So all are showing optical isomerism. Any doubt? Okay, one more question. Here you see this question. This is actually a new kind of question what I have prepared previously. First, you listen the question properly. Whenever they use molecular formula, you must be very careful that all structure must have the same molecular formula. So formula is basically C4H6Cl2, what I have mentioned here. Now you listen. Compound and total number of, not total number of stereoisomers, just statements. Right? Yes, statements that you need to match. These three compounds, suppose, are matching with 1, they are matching with 2, they are matching with 3, they are matching with 4. So you need to put the answer A, B, C, D, suppose 1, 2, 3, 4 or 4, 1, 2, 3, and that 4, 1, 2, 3 will become the integer part. So like that, first you need to match and then simply write what is the answer of A, then B, then C, then D, and what the numeric value you are getting, that will be the integer answer. Now you match. This question is also fit for JEE advanced paper. Because this is new kind of format what I have prepared. Matching list, but the answer is in integer. Usually JEE always try some new formats. So I thought that kind of format they may use.
So 21314.
2134. Anyone is getting the same answer? 2134,
2134, sir.
2134, right?
2314.
Beta, Sheikh Mastan, I'm not getting it. 2134, same you are saying?
2314, sir.
2314. Okay. Okay. So can we start discussing this? All are constitutional isomers. Constitutional meaning is structural isomers. So structural means bonding pattern must change. Hey, you know the basic definition of a structural and stereo? A structural meaning is like a bonding pattern must change. Should I explain the statement or everyone got the point? Bonding pattern must change.
Yes, sir.
You got. Okay, right. So in this case, these two carbon are having 1 Cl. Here bonding pattern change. Cl removed from these 2 points and attached here. In this case, again bonding pattern change. Cl directly attached to one Cl attached directly to ring, other on the carbon. So they have different bonding patterns. So they are structural isomers. Okay. All are meso compounds. They are meso compounds. Plane of symmetry between two chiral center, plane of symmetry between two chiral center, plane of symmetry between two chiral center. All are meso compound. All have two-fold axis of symmetry. If I rotate about this y-axis, the molecule reappear again. If I rotate this compound on a z-axis, so the molecule will reappear again by 180 degree. If I rotate by y-axis 180 degree, molecule reappear again.
Fail to detect.
So two-fold axis of symmetry. Overall solution is optically active. Overall solution is optically active, meaning is these two are enantiomers. If you see, they two are enantiomers, mirror image of each other, right? But this one is isomer, but not see here we have two compounds with the same actually like a more percentage, and this is the single one. So out of these three, no. These two, sorry, these two are enantiomers. These two are enantiomers. Okay, just a minute. I remove this. Yes. These two are enantiomers. CH2Cl, CH2Cl. This is not the isomer, stereoisomer of these two compounds. And this is optically active. So if these two cancel out each other, but in the solution, because of this, the overall solution will be optically active. So it is matching with this. So if I write A, B, C, D, A is matching with the 2, B is matching with the 1, C is matching with the 3, and D is matching with the 4. So answer is 2, 1, 3, 4. You got this point? Any confusion you are having? Anyone is having any confusion regarding this question?
Sir,
Yes.
while checking for meso, we also have to check कि अगर उनका कोई optically active वाला भी होना चाहिए.
Which case you are checking? Come on, yeah. Simply check meso, na symmetry between two chiral center here.
Okay.
This is the basic question of IUPAC, because sometimes JEE Advanced ask IUPAC question just for the cyclic, cycloalkene or cycloalkane or benzene type cases. That's why I have kept very standard question. Only 2 points are required. One is parent chain selection. Second point is numbering. If you suppose do these 2 points correctly, you will get the perfect answer. Find the sum of position number X, Y, Z, W assigned to bromine according to IUPAC rule. You simply do the numbering. So I just want to check whether you know how to keep numbers in parent chain. That is the only point of discussion.
Sir, 21.
21. Okay, we'll check it. Any other answer?
Sir, 16.
16. Okay.
Sir, 12.
12. It means that many of you are wrong, right? Because all are different answers.
Sir, 15.
Okay, one more different answer we are getting. Okay, let me finish first. In this case, functional group is having the first priority, and when we have functional group directly attached to ring, we start numbering from the ring carbon which is directly attached to the functional group. Once you start numbering this, you have to finish the double bond completely, then only you can move. So 3, 4, 5, here Br is on the 5th position. Is that okay? Here this is the functional group. If this is the functional, so this will become side chain, and in side chain and multiple bond, priority goes to multiple bond. So 1, 2, 3, 4, 5, again we are getting 5. We start numbering from the double bond. These are the two location of double bond, right? So then first side chain must get the lowest number. So numbering should start from this position and then finish the double bond completely. Then only you can move forward. So now we are getting 6 number. We need to start numbering from the double bond. Both the double bond can be 1, but first side chain must get the lowest number. So 1. Then double bond should completely finish. 2, 3, 4, and 5. So this is a 5. So answer is 21. 21 is the perfect answer. You must know how to number in the standard compound only. Okay, I'll tell you if you are not aware about this parent chain. First, you listen my point, how to select the parent chain. First thing is functional group must be there in the parent chain. If functional group is having carbon, that carbon should be the part of the parent chain. Or if functional group suppose is having carbon, that carbon should be the part of parent chain. If it is not having carbon, then the carbon to whom it is attached, that should be the part of parent chain. Then maximum number of multiple bonds should be included in the parent chain. Then you need to maintain the length, maximum length. Then those carbon to whom side chain get attached, they must be the part of parent chain. Now, if you go for the numbering, we always start from the corner. We always start from the corner in such a manner that functional group first get more priority. If it is carbon containing, then that carbon must be the number 1. Or if it is non-carbon containing, so start in such a way that the carbon to whom it is attached, that should get the lowest number. Then maximum number of multiple bonds should get the lowest number. Then the carbon to whom side chain attached, that should get the lowest number. This is the just basic rule. You will never get fail in writing the IUPAC name. You will only get fail in 2 rules only: parent chain selection and the numbering. IIT always use some standard structure and they will try to make you trap in the numbering part or in the parent chain selection part. So such type of standard question they will always ask. They will never give unnecessary compound, complicated compound, because they are able to trap you in such simple questions only. You already got trapped, right? Okay, now the next question. This is somewhat good one question. Compounds, and here you need to check total number of stereoisomers, and then listen, and then you need to write the answer in A, B, C, D integer manner, right? What at A attached to which, B attached to what, C attached to what, D attached to what, right? That answer you need to give.
ये तो डाल चुके हैं ना, इंस्ट्रक्शन डालो 1 से 2 और 2 से 3।
हाँ,
आपने डाल दिया
इन लोगों ने बताया, मैंने अभी आपको बताना पड़ेगा।
अच्छा, नोशन में डालना है।
हाँ, और अभिषेक को जूम लिंक भी क्रिएट करना पड़ेगा इसका।
ये फिर एजिस वाला कितना मुझे बस
ये कल तो बैठ ही नहीं रहा।
अच्छा,
SRPQ।
हाँ बेटा,
सर
SRPQ।
सर 4321।
सर SRSQ।
सर SRPQ1।
SRPQ, sir.
okay, SRPQ, okay, now I'll tell you. This is only one chiral center, so 2 stereoisomers, right now. So this is with this. Here we have 2 chiral center, but only like symmetrical compound. So RR, SS, or RS or SR. So answer is 3, SR. In this case, this is not the chiral center. This is chiral center. This is chiral center. This is chiral center. For the three chiral center, what value can be? RRR, SSS, RRS, or RSS. That only. Because this is open chain compound. Hey, don't write, okay, sir, now SSR, and don't write like S Hey, this is just stupidity. Simple is an open chain compound. Whether you write simple RRS or SRR, that is the same thing. Getting my point? So answer is 4. Here, this is a pseudo-chiral center. Again, answer is 4. So means A, B, C, D. A attached with S, B attached with R, C with Q, D with also Q. So S, R, Q, Q.
सर सी वाले में मतलब सिमेट्रिकल है तो और कम नहीं हो जाएंगे?
Guys, how? Just tell me. Just tell me what should be the configurations. I said simple. I said very simple thing. 3 chiral center, right? These 3 can be RRR. That is okay. The 3 can be SSS. The 3 can be 1R, 1R, 1S. What is wrong in that? The 3 can be RSS. What is wrong in that? And other than 4, nothing is possible. Or this is anyway pseudo-chiral center. Pseudo is always having like 4 stereoisomers. Should I explain this? Okay.
Yes, sir, once.
Pseudo you don't know?
Not clearly.
Okay. Pseudo is basically MEME. Let's say if I write HBr, HBr, HBr. Right. If I write like MEME, HBr, HBR, and BRH, right? If suppose I write MEME, HBR, BRH, and HBR, right? And if I write here BR, BR, and H, BR, BRH, BRH. Only 4 possibilities we are having. See, if you try to get this configuration, so priority 1, 2, 3, 3R, that will become S because the 4th priority is on the horizontal position. This will be 1, 2, 3, S, that will become R because 4th is on horizontal position. Here, if you check 1, 2, 3, R will become S, 1, 2, 3, R will become S. Here, 1, 2, 3, R will become S, 1, 2, 3, S will become R. Here, 1, 2, 3, S will become R. This is also R. Now you listen. In this case, in second case, if you want to get the configuration of the middle carbon, this first priority is BR, second, suppose up first priority is BR for the second carbon, right? Okay, I'll show like this. First priority is this one, say this BR. 4th priority is H. You cannot explain second and third. If you go upside, you are having HBr methyl. Here also HBr methyl. Upper one is S, lower one is S. So middle one is not the chiral center. So here we are having only 2 chiral center. Same here. This one, first priority BR, 4th priority H for the middle carbon. And if you go up or down, you are not getting point of difference. So again, we are having only 2 chiral center. So here we are having only 2. Here we are having again only 2. In this case, first priority BR, second priority H. I'll show you. First priority BR, 4th priority H. Out of S and R, third priority goes to R. So 1, 2, 3, right? Clockwise, but 4th priority is on the horizontal position. So R will become S. This is called small s. This is called small s. I'll show you. Again, this is first priority BR, 4th priority H. Out of RS, this will get third priority. That is get second priority. That is get third, because in R and S, priority goes to R, right? So in this case, 1, 2, S, that will become a small r. Now, what is the meaning of pseudo-chiral center? The chiral center whose chirality based on the others configuration. In this case, BR first, H4, you go up or you go down. You are not getting point of difference. You can't define the chiral center here. But in this case, first priority BR, fourth is H, third is R, fourth is S. If they are not R or S, the second middle one cannot become chiral center, like SS. Second not become chiral center. If they become R and S, the second become chiral center. It means it's a chirality based on the others configuration. So the chiral center whose chirality based on the configuration of others, they are called as a pseudo chiral center. So here we are having these two capital S, capital R and small s. Here we are getting SS. Here we are getting S, capital R, small r. Here we are getting RR. So here we have two pure chiral center. Two pure chiral center. Here we are getting two pure, one pseudo. Two pure, one pseudo. Pseudo means not real chiral center. It's chirality based on the others configuration. If others are SS, it become non-chiral. If others are SR, it become chiral. If others are RR, middle one is not chiral. If others are SS, middle one is not chiral. If others are SR, it become chiral. Right? So whenever we are having pseudo chiral center, you just listen why we are getting 4 in that case. In pseudo chiral center, you will get 4 stereoisomers. How? Both are RR, middle one becomes 0. Both are SS, middle one becomes 0. Both are RS, now become chiral center, either small r or it can be small s. That is why in pseudo chiral center case, we get 4 stereoisomers. You got my idea?
Yes, sir.
Okay. Now see this question. This question again I have framed from Peter Sykes. This question I have prepared from Peter Sykes. Now you please check.
ACD.
ACD. Okay. ACD. Again, fit for JEE Advanced, this question. And from Peter Sykes, they have already asked the question. As it is, from the theory, they have prepared question from Peter Sykes. So, high possibility of such type of, I'm not saying exact question, but there's high possibility of same type of questions. They may come in JEE Advanced.
Sir, AB.
A and B. Okay.
Sir, ABD.
ABD. Okay.
So only D.
Only D. Okay.
उसमें केमिस्ट्री का उसका
जो उनका शांति
विप्लव
एक बार बच्चों को उनका टेस्ट आ जाएगा Yes, boys, come on, tell me.
Sir, A, B, and C.
Hmm. Answer is B and D. झटका लगा लगा कुछ शौक सा. Answer is B and D. Nice question actually, and not the tougher one. I told in first or second section. I think. Okay, first thing what I am going to discuss with you. That day also I told ortho effect in benzoic acid. You remember or not? This is the okay. I'll tell you one order first. एक मिनट. Yes. So उनका तो कल रख सकते हैं. हाँ, जब भी चाहे.
संडे इसलिए मॉर्निंग में आ सकते हैं.
When? नहीं तो मंडे रख लो. मंडे तो आ ही जाएंगे वैन से. मंडे रख लो, फिर मंडे साल का हो जाएगा. See, बच्चों, now first thing is what you need to actually learn first is, suppose here we have OH. Now listen, okay, I'll write more bigger picture. COOH, right? Here we have OH. This O, suppose do resonance, this O is getting negative charge, right? And this H, because this is showing plus M effect, so O will get positive charge, pull the electron of H, H is also getting positive. So H bonding is in between the oxygen of carboxylic and hydrogen of OH, phenolic OH. This H is not participating in like hydrogen bonding. What you are thinking in that OME case, if you are thinking that this H will do H bonding, how it is possible? Yeah, this is in resonance. O get positive charge, pull electron, also get positive charge. This is in resonance, also get positive charge. How positive can make hydrogen bonding? Yeah, it means in both the compound there is no hydrogen bonding at all. So third, fourth compound, they are not having H bond. This statement itself is wrong. Intra H bond, right? So this statement is very much clear. Now, as per the H bonding concept, this is the best acidic among all. That is okay. pK value is around 1.22, something like that. After then, this is only having H bonding. They are not having H bonding at all. A bit steric effect may apply in the fourth. So answer will be 2, then 1, then 4, then 3. Because the steric factor is not playing major role in OME case. Well, sir, why? The reason is O is having 2 lone pair, then methyl. O is having 2 lone pair, then methyl. And why the methyl will turn towards the OH, COOH side? They will always try to get less steric factor. So it will rotate like this, so that lone pair should face the face of this carboxylic acid. It will turn like this. So there is no major steric factor is working in this methoxy-methoxybenzoic acid. A little bit steric may work. So best answer is 2. Then 1, at least the minus charge of COO minus is stabilized by hydrogen bonding. Here we have 2H bonding after releasing the H plus. After releasing the H plus, 1H bonding, no H bonding, a little bit steric factor if work. So fourth become better acidic than the third. So answer is 2, 1, 4, 3. So this is again wrong. Second statement, pK difference in between these two, because both the two are good acidic. Here we have difference 1.22 and this is somewhat 2.34, something like that. Here in this case 6.764 or 6.9, this is 6.73, because both are the waste acidic condition among the four. So here the pK difference is very less. Here the pK difference is more. So magnitude of pK difference in first and second is more as compared to third and fourth. This kind of question JEE Advanced already have asked for the basic strength case. I have prepared the acidic strength question. Are you getting my point? So this is a good question actually. That kind of question they may ask in JEE Advanced. And directly I have prepared from theory part of Peter Sykes. So you must please keep this question in your mind. Okay, now see this question. Again fit for JEE Advanced. Just a minute, bachcho, just a minute. Haji bachcho, what is the answer?
So B and D.
B and D. Okay, just a minute. We need to check this. Correct statement. First thing is correct statement they are asking. The rate difference, first thing is, this is this is regarding SNAR reaction. Yeah, right. This is SNAR reaction. So this withdrawing group will create positive charge here, positive charge here, like that, and a nucleophile will attack. That is the basic idea of the question. Here minus M is working because of the two bulky group. Nitro will turn around and instead of minus M, only minus I is working. Here minus M. Here C triple bond N. This is the case. If suppose even after steric crowding, if it is turn around, so one pi got turned around, other pi will become parallel. So every time it will show minus M. Because here we have 2 pi bond. 1 pi suppose turn around, other pi will come in the parallel mode. So then other pi minus M will work out, right? So anyhow, so only this is the waste factor, because here nitro turn around become only minus I, remaining 3 are minus M. Out of the 3 minus M, nitro minus M is more powerful. Then Cn and Cn. Out of these two Cn, this Cn is more powerful because here we are getting 2 plus I also. So now rate difference between third and fourth is more as compared to first and second with NaOH. No, yeah. First second rate difference is more. First will show SNAR, second won't show SNAR. Rate difference between third fourth is less as compared to first second with NaOH. Yes, this statement is correct. First and third react with the same rate. No. First is faster than third one. Resonance effect is more in first than second. Yes, resonance effect is more. Right. So answer is B and D. Correct only. Correct, bachcho? This question, you check this question.
Option C, sir.
Option C. Option C. Third and fourth. Okay. और कोई?
B option.
Yes, sir. C option. C option.
C option. Okay.
Option C.
Which one?
C, sir.
C. Okay. Yes, absolutely. Answer is C. Because we are adding hydrogen. So we are getting answer butane in both the case. There is no meaning of that trick. Cis, syn, meso, trans, syn, racemic. We are not getting meso, racemic. We are getting non-chiral center compound because we are not adding deuterium. We are introducing hydrogen. So neither stereospecific nor is like a selective. Syn addition, that is okay. Whether you add hydrogen or deuterium, reaction is a syn addition. Rate of formation of M is faster than N. Yes, cis is always faster than the trans condition. Right. Perfect. Answer is C. This one. These are the question during the JEE advanced exam. In middle only, they just keep one easy type question also. Because all question you will never get like tough in JEE paper. So sometimes they keep very simple question and most of the students do mistake in the simplest question only. Right?
B and C.
B and C.
Yes.
Tell me anyone?
BC.
BC. Yes, absolutely BC. It means you guys have done this black book, na? I am feeling like this. Huh? Yes, soda lime decarboxylation, CO2 gone, we are getting propane. Decarboxylation, CO2 gone, we are getting propane. So answer is B and C. Very good, very good. Anyway, but good. This question we have done before or not? No, this we have not done. Okay, before this, first you solve this integer.
Seven, sir.
7.
Which one?
7.
7.
What is the value of x plus y?
7, sir.
The x value is?
Sir, X is 3.
3 plus 4.
Yes, very good. Answer is 7 only. Yes. So you got this answer. Tell me.
Yes, sir.
This one? Cl gone, cation rearranged to this, cation rearranged to this, like that. Okay. Okay, now you please try this question also. How many of the following synthesis will fail to give following as a final product? Or you must be dare enough to say answer 0 also. Always remember in JEE Advanced, most of the students, they get fear to write answer 0. I'm just telling you, in such type of cases.
So 1 and 2.
So 1 and 3.
नहीं integer answer देना है, like how many, they are not asking the sequence number. How many?
2.
2. Very good. So all done. All done. Very good. So first, because after nitration we'll get NO2, and once a strong withdrawing group attached, we cannot do Friedel-Crafts acylation reaction. So this reaction cannot happen. Again, nitration after a strong withdrawing group, we cannot do Friedel-Crafts alkylation. Again, not done. NBS will create Br here. Then this is elimination reaction. So we will get this alkene. Once you get this alkene, or you provide Br2 FeBr3, you will get the compound like this. 1 Br here, 1 Br here. So this again, it is wrong. Hey, tell me just a simple thing here. I'm asking very simple thing. Suppose if you are having benzene with this double bond, here you have Br2. In simple alkene case, when you attack on Br2 anti-addition, when you say you attack and this like this, you will get first a cyclic bromonium ion and then Br minus you attack. That is okay? Okay. Here I am providing Br2 FeBr3. What does it mean? It meaning is Br2 FeBr3. This is a Lewis acid. It is giving electron to Fe, and when it is taking, so here I am getting, instead of neutral, I am getting positively charged electrophile here. So alkene will attack fast or benzene will attack fast. Anyway, it is difficult to break the aromaticity of benzene. So who will attack faster, alkene or benzene? Alkene, obviously. Or instead of neutral Br2, I am providing Br in an electrophilic situation. So whenever alkene is attached with benzene, so the reaction like hydrogenation, ozonolysis, HBr, Br2 addition, all will happen with alkene instead of benzene, because benzene want more activation energy. So all three reactions are wrongly attached with the product. All products are wrong only. This is the question. I have got the theory from Morrison Boyd. These all questions I have prepared from theory only. No question I have cut and paste from any book. So this is given in Morrison Boyd exercise, actually. So for today, it is enough. If anything you want to say, you can say.
Sir,
Next.
do you recommend at this point start reading some points of Peter Sykes, maybe for theory?
It is not a good time actually. If you are having some extra time, then it is okay. Otherwise you should go for better practicing. I told you if you have that black book you please solve a black book question. All that kind of questions are there in the black book. Otherwise I am solving here only in the screen, Zoom link.
Sir, do you have its PDF?
I have PDF. I can share that PDF to you.
Yes, sir. Thank you, sir. Please.
Okay, I'll share that PDF to Prasad sir. Prasad sir will give you. Okay.
For chemistry in everyday life, NCERT is sufficient for advanced. Right?
I can teach you chemistry in everyday life in coming week. I will only teach you. I'll share you. Okay, I'll show you something. I'll show you my book. That also I can share, and you just go for that book. This is my NCERT of chemistry everyday life. Where is the chemistry everyday life? Okay, I'll show you just a minute. This is chemistry everyday life. So I have done postmortem of the NCERT, right? Coming week, I'll teach you this topic. You will get better confidence. Or I'll share my book, PDF. Okay, ji.